So in this one, they give us an electric circuit with a switch that's open. And the question is, when the switch is open, there is electric current where? So if the circuit is open, it means electrons can't get over to this section of the wire. So electrons can go down here and get through 1, but it can't get to 2 and 3. So lamp 1 only will be lit. In this one, there's a lot going on in this one. The diagram represents a 3 ohm resistor with a 12 volt battery, and they've got these 2 meters that are X and Y. So we know that meters measured or wired in series are ammeters and in parallel are voltmeters. And this is going to read the total voltage, so that's 12 volts. And we can use V equals IR to get the current. So the current is 4 amps. So we know the voltage is 12 here and the current is 4, and that's the answer. Okay, this one says a combination of 2 identical resistors are in series, and it has an equivalent resistance of 10 ohms. So in series, how is that possible if the total is 10 and they're both the same? Well, in series, you add the resistors, so that's 5 plus 5. What would the equivalent resistance of these combinations be if the resistors were in parallel? Well, in parallel, we use the rule for resistance in parallel circuits. Again, we do x to the minus 1 plus x to the minus 1 on those 5 ohm resistors, and then you have to hit x to the minus 1 one last time. The current in a wire is 5 amps. Calculate the total amount of charge in coulombs. So this is a 2-step problem. Actually, no, I'm sorry, it's not a 2-step problem. You can just do it with I equals Q over T. They give us the 5 amps. We're looking for the charge in coulombs, and the time is 36 seconds. I was thinking about the number of electrons, and to do that we'd have to divide by 1.6 times 10 to the minus 19th, but they didn't ask for that. I have no idea why they had to include a picture of a light bulb here. I think everybody knows what a light bulb looks like. Anyway, we have a light bulb with a thin tungsten wire. Tungsten means that we know we can look up the resistivity of tungsten, which is here on the reference table. And it says it's 0.22 meters in length, and they tell us it's 19 ohms. The 20 degrees Celsius just tells us that the number on the reference table is good to go. So that's just going to be an R equals rho L over A, and that gives us the area in meters squared. So the next question says, explain why the resistance of the tungsten wire filament increases when the bulb is being operated compared to the resistance of the filament at 20 degrees Celsius. Well, what's going to happen when it starts to run? Well, the resistance starts to go up. Why? Because the current starts to flow through and heats up the filament. We know that as the temperature goes up, the resistance goes up. So my solution was just to say when the operated temperature increases, so does the resistance. And then to calculate the power, that's just going to be a straight up P equals V squared over R. They gave us the voltage, they gave us the resistance, so the power is 60 watts. It's a 60 watt light bulb. Copper is a metal commonly used for electrical wiring houses. Which metal conducts electricity better than copper? So for that, we just have to go to the chart. Here's copper. The only one that's lower than that is silver. So the answer is silver. When one light blows out, an entire string of decorative lights goes out. Well, if one light goes out and the rest go out, that means it is in series, and there's only one way for electrons to go, and that's our choice. The last question here gives us a toaster of 1200 watts, so that's our power, 120 volts, which we actually don't need. And what's the total electrical energy? That is W, to operate the toaster for 30 seconds. So actually this isn't really an electricity question. We can just do P equals W over T. So we know it's 1200 watts, run for 30 seconds. To solve for the energy, that's 3.6 times 10 to the 4th joules.